Good day guys, we are now looking at how to calculate second moment of areas in Math N6. So we'll go through this question. It says calculate point of intersection of the two curves y equal to x squared minus 1 and y equal to 2x plus 7. Then you show your representative strip that you use to calculate the bounded area. That's the first part. Second part will calculate the area. Second part will calculate the second moment of area about the y-axis. Then the last part will express our answer in C in terms of the area. So let's go to the first part. Point of intersection, we've got y equal to 2x plus 7. That's my first equation. Y equal to x squared minus 1. That's my second equation. So equation 1, as you can see, it's the same thing as equation 2, since it has y on the left hand side. What does that mean? X squared minus 1 is equal to 2x plus 7. So if I take everything to one side, I'll get x squared minus 2x minus 8 is equal to 0. So it's now left for you to solve this equation. You can use factorization, you can use the formula. When I look at it, it looks like we can take x minus 4, I think so. Is it into x plus 2? I guess so. So if you multiply that, that's x squared, 2x minus 4x gives us that, yeah. So factorization can go. You can also try the formula if you wish. Any method you want is fine. So that will lead us to x equal to 4 or x equal to negative 2. Then if you calculate the corresponding y values, if you put x as 4 into any of the equations, 4 squared is 16. 16 minus 1 is 15. It means y is 15. Then if you use negative 2 squared is 4. 4 minus 1 is 3. So therefore our point of intersection are 4, 15, and negative 2, 3. So once I know point of intersection, to sketch the graphs become easier for me. I see that this point is in the first quadrant, that is in the second. So that reminds me that I need the first and second quadrant to sketch my graph. So that's exactly what I'll do. So that's my y on the first quadrant. I can say this is my 2 and that's my 4. Second quadrant, that's my negative 2. Then the other one, we need up to 15. So maybe I can say that is 3, 6, 9, 12, 15. So I need the point 4, 15 is somewhere there. Up there, the point negative 2, 3 can be somewhere there. So in those two graphs, you will see that the first one is an equation of a straight line. To sketch a straight line, all you need is 2 points. So I see my 2 points, I can just link them up. I see my straight line, I'm done with my straight line. Now for the parabola, it's the sad face. Sorry, it's the smiling face, because A is positive, so I expect it to go like that. So that's how easy it is. Then if I want to know where it touches the y-axis, I make x 0. If x is 0, y is negative 1. So it means I need a certain negative 1 down there. So if I'm sketching my graph, it must touch the turning point at negative 1. So it must touch the point of intersection and negative 1 on the y-axis, since if x is 0, y is negative 1. So that's more than enough information to get us to the correct graph. So that's how simple it is. So I'm done with my shape. If you're interested in more points, if you get y as 0, you'll see that x is negative 1 and 1, so that can be a negative 1 and 1. But I guess that's not so important for us here, as we have already seen the area bounded by the two graphs. So that's my area bounded by the two graphs, and that area exists between negative 2 to 4. So that is it. Now it's time to put a strip in the shaded portion. So So looking at that shaded portion, the best strip here should be vertical. If you know that a strip should always forever touch two graphs. So see, if I put a vertical strip, I keep on touching the straight line and the parabola. Whether I put it on the right, the left, or the center, the shaded portion is the same thing. But for horizontal, I will find myself with a challenge because once I get across this point, I start touching the same graph, which doesn't make much sense that a strip touches the same graph. So I'm putting my strip. So that's my strip between the two graphs. I can put it anywhere I want. Between the two graphs, it's touching the x-axis, telling me that I must be integrating with respect to x. Then the next thing is that it's vertical like the y-axis, telling me that I must level my two graphs using y. So my first graph passes above the strip, which is the straight line. My second graph passes below the strip, which is the parabola. So I'm done with the A part. I can now go to the B part. So to calculate the area, as we asked in the B part, I need to know whether my area starts with AX or AY. If you go to page 4 of the formula sheet for N6 students, you'll see that we'll be circling for this one because your strip touches the x-axis. Those formulas are there on your formula sheet, and your formula must end with a dx. Why is it ending with a dx? Simply because your strip says so. So that's your formula. Then you can now start substituting a and b. You read from the x-axis where you start at shading to where you start. So that's from -2 to 4. y1, you can see it there, 2x plus 7, and then minus y2, which is x squared minus 1. So if I now open the inner bracket, I will have my 2x is still staying, it's alone. Then 7 minus 1 is 8, then minus x squared, this bracket plus 8 minus x squared. So that's what I'm settling for. Then I can now integrate. If I integrate the first term, I get x squared because it's supposed to be x squared over 2 plus 8x minus x cubed over 3 from -2 to 4. So I can now put my limit. I'll put the upper limit where there is x. 4 squared is 16, 4 times 2 is 32, 4 cubed is 64 over 3, that's my upper limit. My lower limit, -2 squared is 4, -2 times 8 is -16, -2 cubed is -8 over 3, then with this other negative it's 8 over 3. So what I need now is to go through my calculator and see what I get. So I'm getting 16 plus 32 minus 64 on 3. Then if you open the bracket there, it's -4 plus 16 minus 8 over 3. So that gives us our area as 836 unit square. So that's our area. You can now go to the second part. Second moment of area, that is the C part. The second moment of area, about what axis? The question said about the y-axis. So for N6 students, you simply go to page 5 of the formula sheet and look for IY, which is defined as the integral from a to b of r squared dA. So the way this thing is done, you're supposed to copy that formula, then you develop it using your diagram. So the way I develop it is very simple. Your r is a distance from the center of your strip to the axis written there. So the axis written there is the y-axis. So to get your r correctly, you go to your diagram, you do it practically. So I start from the center of my strip. You see my strip on my diagram is vertical. I start at the center, then I move in a straight line to the y-axis. I see that my red line there is horizontal. So anything horizontal, you write in terms of x. If it was vertical, I will be using y. So my r is a simple x. So that's the distance from the center of my strip to the y-axis. So since we need r squared for second moment, it means I'll be writing x squared. Then my dA is simply the same formula that I use for my area, which is y1 minus y2, dx from a to b, a and b are the same figures, negative 2 to 4, then x squared. Now you must remember that y1 minus y2, you started here and ended here, so you can just copy from there. This is 2x plus 8 minus x squared dx. Then you open your bracket, you will get the integral from 2 to 4 of 2x cubed plus 8x squared minus x to the power 4. All this dx. Then integrate, you will get 2x to the power 4 over 4. That is just a half of x to the power 4. Then you get plus 8 over 3x cubed minus 1 over 5x to the power 5 from negative 2 to 4. So we can continue with this side. If we substitute the upper limit, we need 4 to the power 4. So we need 4 exponent 4. That gives us 256 divided by 2. Gives us 128. So we have 128. We're going to put 4 there. 4 cubed is 64. So 64 times 8. If you put 4 there, cube is 64 times 8 is 512. So it's plus 512 over 3. Let's see if that one is right. It's over 3. Then minus 4 to the power 5. 4 to the power 5. In my calculator is 1024, which is over 5. So that's my upper limit. Let's go to the lower limit. If we take negative 2 to the power 4, 16 divided by 2 is 8. Negative 2 cubed is negative 8 times 8 is negative 64. 3. Negative 2 to the power 5. 2 to the power 5 should be 32. Times negative 1 over 5 gives us positive 32 over 5. So we can now simplify this on the calculator. We get 128 plus 512 over 3. Then minus 1024 on 5. Then minus 8. Then plus 64 on 3. Then minus 32 over 5. This should be 32 over 5. Minus 32 on 5. So that gives us 992 over 15. That's our second moment. If you're interested in unit, you can call u to the power 4. If you prefer decimals, it's still not a problem, which is 66,133 to the power 4. So that's how you get your second moment about the y-axis. Then the last part, which usually says write your answer, express the answer in C above in terms of the area. What you simply do is you copy this answer, which is 992 over 15. You divide this answer by the area. Our area was 36. Then you multiply by capital A. That's how you write the answer in terms of the area. So I'm dividing this by 36. That gives me 248 over 135A. Or if you prefer it in decimals, you'll say 1,837A. So that's how to calculate second moment of area and write the answer in terms of the area. Thank you very much.